So this video is to go over your parametric review and make sure that you can do these problems because they're very similar to things that could show up on an assessment. So the first set of problems asks me to make a table of values for the time interval they're given, graph the curve, and indicate the orientation with the arrows, and find the rectangular form. So number 1 says x equals 2t plus 3, y equals t squared minus 1, and it says that t needs to go from 0 to 4. So if I list my t's across, I can do 0, 1, 2, 3, 4, and then I can list my x's across and my y's across. So here's my table. So I'm just going to plug in the numbers into my equation. So I'm going to start with the t's going into the x equation. When you plug in 0, you get 3. When you plug in 1, you get 5. When you plug in 2, you get 7. When you plug in 3, you get 9. You plug in 4, you get 11. Now I'm going to plug the t values into my y equation. Plugging in 0, you get negative 1, 0, 3, 8, and then 15. So if I want to graph that, it's mostly in the first quadrant, so I'm going to kind of shift over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 11. So my first dot, remember you're only graphing your XY set of ordered pairs in this yellow box. You're not graphing the t's. So my first ordered pair is 3, negative 1, and then 5, 0, and then 7, 3, 9, 3, 4, 5, 6, 7, 8, and then 11, 15. Since I had finite time values, I cannot put arrows on the ends of the graph because it starts here and stops here, but put the arrows on the curve that indicates how a particle would move along the shape from where we started to where we finished. And now I'm going to convert it. So I'm going to take my x equation, I'm going to solve for t so I can plug it in. So x minus 3 over 2 equals t. I can plug that in. So y equals x minus 3 over 2 squared minus 1. Y equals, I square the top and the bottom. I'm actually going to pull the 1/2 out and make it a fourth, because when you square the 2 on the bottom, you get a fourth. That leaves me with x minus 3 squared minus 1. So we can see from that equation, it's a parabola. The vertex should be 3, negative 1, with an a value of 1/4. So this is just one side of the parabola. Y equals 1/4. X squared minus 6x plus 9 minus 1. Y equals 1/4. X squared minus 3 over 4 is going to be 3 halves x plus 9/4. And I'm going to write this 1 right here as 4/4. So I can add these two fractions together. So that gets me y equals 1/4 x squared minus 3 halves x plus 5/4. So here's the equation converted. I could have also left it in vertex form up here. I made a table and made a graph. So we're going to do the exact same process for problem number 2 and problem number 3. You can pause the video and try those problems and then start the video again, and the answers will show up on the screen. So I made a table of values. I plugged them in. The y row was very easy because it says y equals t, so I just copied them down. Then I drew my graph, and my dots appeared in order from over here, like this. So my arrows indicate that direction. And then my conversion was really simple because it says y equals t. So I took my x equation and I rewrote it with a y in it. So x equals the absolute value of y minus 2. Absolute value we usually say is a v, and we usually have the x and y switched. So since the x and y is switched, it's in a v, it would be a sideways v opening to the side like my graph does. Go ahead and pause again and try the next one. So I plugged the values in, and I'm getting a piece of a sideways parabola. I know it's a parabola because the x equation has the square in it. So when I plug the y equation in, I get my boxed item from my x equation, and then here's the piece of the parabola. The other piece is probably down here, somewhere like that. But it doesn't look too parabolic-ish, only because I'm only looking at a piece from 0 to 3. So the next set of equations, it says that I'm going to determine what conic section is represented by the curve. I'm going to graph the curve from 0 to pi, indicate the orientation, and then find the rectangular equation and model it. So let's go ahead and try one. So number 4 says I have x equals 5 cosine t, y equals 5 sine t plus 3. So I'm just going to go on a limb and say a couple things. Since it's sines and cosines, your only options, and they're not squared, they're just straight up sine and cosine with x and y, it's going to be a circle or an ellipse. This is going to be a circle because the two coefficients in front of the trig functions, 5 and 5, match each other, so the stretch is going to be the same. But if you didn't know that, you can tell me all of those things after you convert it. I need to make a graph, and since we're making tables, let's keep making a table. And since it's conic sections with trig, we'll try to make this very easy and pick 4 nice ones. I'm going to pick 4 numbers around the circle, 0 to 2 pi. I'm going to pick 0. This is kind of like my theta. I'm going to pick pi over 2, pi, 3 pi over 2, and then 2 pi. So I plug in 0 to my cosine equation. Cosine of 0 is 1. 1 times 5 is 5. If I plug pi over 2 into my cosine equation, cosine of pi over 2 is 0. 0 times anything is 0. Cosine of pi is negative 1 times 5 is negative 5. Cosine of 3 pi over 2 is nothing. Nothing times anything is 0. And then 2 pi is the same thing as 0, so a 5 again. Plug them into your y equation. Sine of 0 is nothing. Nothing times 5 is nothing. Plus 3 makes a 3. Sine of pi over 2 is 1. 1 times 5 is 5. Plus 3 more is 8. Sine of pi is nothing. Nothing times 5 is nothing. Plus 3 more is 3. Sine of 3 pi over 2 is negative 1. Negative 1 times 5 is negative 5. Plus 3 is negative 2. And then 2 pi is the same thing as 0. 3. So I draw this equation. I'm going to graph it on an xy plane. I go sideways. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And I go down 2. So 5, 3. And then 0, 8. Negative 5, 3. And 0, negative 2. So you can see this. Granted, I did not draw very well. My center is right here. Oh, and we all know that I'm not the best drawer. It's going to look a little ellipsish because my thing wasn't correct, but it's a circle. And when I drew my dots, this one, then this one, then this one, then that one, it's the order they appeared. So we're going to spin just like we go around the circle, unit circle in a counterclockwise motion because x has cosine and y has sine. If I want to convert this, remember I have to have my Pythag. I have to have that cosine squared x plus sine squared x equals 1. So I'm going to do the cosine first. X over 5 is going to equal cosine t, and then I need to square both sides. So x squared over 25 equals my cosine squared t. Same thing with the sine stuff. I'm going to subtract the 3 over and divide by 5, and that equals sine t. But I need it squared, so I'm going to have y minus 3 squared over 25 equals sine squared t. And now I can go ahead and plug it in. Cosine squared was x squared over 25 plus sine squared was y minus 3 squared over 25. And it equals 1. And since we know it's a circle, it should equal the radius. So I'm going to multiply everything by a 25 to move that 25 over. So my answer is going to be x squared plus y minus 3 squared equals 25. It's a circle with a center of 0, 3, radius of 5. So from my center here, I went in all directions 5 units. So go ahead and pause the video and try the next two. So number 5 is cosines and sines. So my options are ellipse or circle. I did my conversions over here, making green dots. And I got that here's my cosine squared, here's my sine squared. So I used my Pythag right here and plugged them in. It's an ellipse. The center is -1, 4. And then I go sideways square root of 1, which is 1. And I go up and down square root of 4, which is 2. And then I have my ellipse with my arrows on it. So pause again and then come back and let's check number 6. Just be aware that number 6 has secants and tangents, so it's not going to be a circle or an ellipse. So since it's tangent and secant, I went ahead and solved and got a tangent squared value, or a tangent squared value equals right here, and a secant squared value equals here, and then I used this Pythag. Secant squared was my y stuff, tangent squared was my x stuff. It's a hyperbola because I got secant and tangent, and so I drew my center, which was 2, 3, and then I go sideways square root of 1, which is 1, I go up and down square root of 4, which is 2, and then I drew my 2 branches and made sure that I had arrows on them. So this is the answer for number 6. The next one says that they give you the rectangular form and they want the parametric of the conic section. This is number 7. So we're going to use our Pythag that says cosine squared theta plus sine squared theta equals 1 because the plus sign in the middle. Cosine's going to be the x stuff. Sine's going to be the y stuff. So I'm going to square root everything, and when I square root everything, I get x minus 2 over 4 equals cosine theta. I need to solve for x because parametrics come in pairs. So I'll multiply the 4 over. Then I'm going to add the 2. So x equals 4 cosine theta plus 2 is one of my equations. The other one comes from the sine and the y stuff. So I'm going to square root everything. I get y plus 5 over 3 equals sine theta. I got to solve for y. Y plus 5 equals 3 sine theta. So y equals 3 sine theta minus 5. These two are my parametric equations. Number 7, we're both in what's called standard form. They're both rectangular. Rectangular means x and y only, but this is standard form because I can look at it and tell you it's an ellipse. Number 8, same idea. This is a circle. So again, circles and ellipses use the cosine squared theta plus sine squared theta equals 1. This needs to equal 1 though. So I need to, before I use this, to divide the 16 over. So x plus 1 squared over 16 plus y minus 3 squared over 16 equals 1. And now the ones match up. So I can call the first piece like this. I'm going to square root, so I get cosine theta equals x plus 1, over 4. So 4 cosine theta equals x plus 1. So x is going to equal 4 cosine theta minus 1. Same idea for the y stuff, square root everything. So sine theta equals y minus 3 over 4. And then multiply the 4 over. 4 sine theta equals y minus 3. Y equals 4 sine theta plus 3. And you can tell it's a circle because The two 4's in front of the trig functions match, so it was stretched the same way horizontally as it was vertically, making it a circle as opposed to an ellipse. Number 8, and I can look at this one and tell you it's a circle. Number 9 is just a little bit different because it says 16y squared minus 9x squared plus 54x minus 64y plus 127 equals 0. This is in general form. General form is multiplied out and equals 0, whereas opposed to this one, which is general, because it's all multiplied out and it equals 0. So I'm going to regroup and move some things. I'm going to pull a 16 out of the y stuff. Y squared minus 4y plus blank. Pull a negative 9 out of the x stuff. X squared. This makes my 54 becomes a negative 6x because a negative times a negative will get back to that positive 54. Plus blank equals negative 127 plus blank plus blank. The y blank, it's b over 2 squared, so negative 4 divided by 2 is negative 2. Negative 2 squared is 4, but you have to bounce it. So 16 times a 4 on this side makes a 64. The x blank is going to be, let's see, negative 6 divided by 2 is 3, or negative 3 squared is 9. Negative 9 times a 9 makes a negative 81. So I'm going to get, 16. The y stuff factors into y minus 2 squared minus 9 times the x stuff factors into x minus 3 squared equals, and you add this all up, it's going to be negative 144. I have to divide everything by negative 144. So when I reduce 16 and negative 144, it's going to make a negative y minus 2 squared over 9. A negative divided by negative makes a positive. 9 over 144 reduces to 16 equals 1. And because the y is negative, I need to rewrite the order. So I get x minus 3 squared over 16 minus y minus 2 squared over 9 equals 1. Because there's a minus sign, we can tell it's a hyperbola. And since we know it's a hyperbola, we're going to use a different Pythag. This time we're going to use the secant squared theta minus tangent squared theta equals 1. These pieces equate. So square root everything. X minus 3 over 4 equals secant. I'm a hyperbola. Remember, whoever you start with gets the secant because the minus sign and order matters. So x is going to equal 4 secant theta plus 3. Square root everything. Y minus 2 over 3 equals tangent. So y equals 3 tan theta plus 2. Here's your set of parametric equations for this one. Number 10 is an interesting question. It says, what is the slope of the parametric equations modeled by what's given? So that should be a dead giveaway, that when you convert it to rectangular form, x's and y's only, that it should be a line. So let's do some math. X minus 5 over negative 2 is going to equal t. I'm going to take that and plug it in over here. So this was step 1. Step 2 is I'm going to plug it in. So I get y equals negative 3. X minus 5 over negative 2. Y equals, I can write the negative 3 over the negative 2 out front. A negative divided by a negative is a positive. And then I can distribute across. So y equals 3 over 2x minus 15 over 2. This is y equals mx plus b. And the slope is the m piece, this piece right here. So the answer is that m, my slope, equals 3/2. Number 11 gives you two sets of parametric equations and asks do they intersect. So let's deal with them piece by piece. X equals 2 minus 3t. Y equals 7 minus 6t. So I'm going to take my x equation first. X minus 2 over negative 3 equals t. And I'm going to plug it into my y equation. Y equals 7 minus 6 parentheses. X minus 2 over negative 3. Y equals 7 minus 6 over negative 3 times x minus 2. Y equals 7. A negative 6 divided by negative 3 is going to be plus 2 times x minus 2. So y equals 7 plus 2x minus 4. Final equation is y equals 2x plus 3. That was the first set. The second set says x equals t minus 1. Y equals 1 plus 2t. So if I take my x equation, x plus 1 equals t, and then I can plug that into my y equation. So y equals 1 plus 2 times x plus 1. Y equals 1 plus 2x plus 2. Y equals 2x plus 3. This line and this line are exactly the same line. So they're intersecting all the time. They always are intersecting. So do they intersect? Yes, always. Touching or intersecting. So let's just like an idea or a thought. I wonder what would happen. Let's just pretend. Let's pretend if I had redone this problem. Let's say that one equation came out to y equals 2x minus 1. And my other equation came out to y equals negative 3x plus 6. Do these lines ever intersect? Well, since they both equal y, I can set them equal to each other. 2x minus 1 equals negative 3x plus 6. I can... Actually, let me make this a little bit better. Let's not make this a 6. Let's make this a 4, so it comes out prettier. I can add the negative 3x to the other side and gets me 5x. And I can add the 1 the other way, which gets me 5. So x equals 1. So they intersect when x equals 1. And then you can take that x equals 1 into either equation and find your y value. Doesn't matter which one you use. Times 1 minus 1. So y equals 2 minus 1, which is also 1. So my intersection point would be 1, 1. So if they're not parallel, we can actually find where they intersect. Okay, the last problem is number 11 again, but it really should be called number 12. And it's the application problem. So let's walk through one more of these. So a baseball is hit from 3 feet above the ground, an angle of 42 degrees. The velocity of the ball is hit with is 90 feet per second. Use parametric equations to describe the trajectory. So x equals v naught cosine theta times time. X equals 90 cosine 42 degrees times time. And we're just going to type this in our calculators, and we're going to write our answer to 3 decimal places. So the directions on your test say to do 3 decimal places. Make sure that when you're doing this, the calculators are normal in radians. So make sure you put that degree symbol in. So there's my x equation. My y equation said negative 1/2 gt squared plus v naught sine theta t plus h. Since the problem's in feet, I'm going to use, Since the problem's in feet, I'm going to use that 32. For the gravity, if it were in meters, you'd use 9.8. And it was 3 feet above the ground, so my h is 3. So again, just going to use our calculator. It's going to be negative 16 t squared. I'm going to do 90 sine 42. And make sure, again, you put that degree symbol in to 3 decimals. She gets 60.222 t plus 3. So there's my 2 equations. This was part A. Part B says, how long will it take for the ball to hit the ground? That means my height is 0. So I'm going to use the y equation because we're talking about a height thing. Oops, that's not what I meant to write, sorry. Copying the wrong thing down. Negative 16 t squared plus... I'm going to have to use a quadratic formula because it's not going to factor. So make sure you know this. So to find my values, it's going to be the opposite of b, so negative 60.222 plus or minus the square root of 60.222 squared minus 4 times negative 16 times 3. This whole thing divided by 2 times negative 16. I'm just going to type that in a calculator and get the two answers out. So the two answers that come out are negative 0.049 and 3.813. So the ball is physically in the air. Negative time doesn't happen. All that means is that the parabola doesn't start down here. It started up here, and so it shifts a little bit. But this is the total time in the air. So t equals 3.813 seconds. That's how long it's in the air. Part C says, how far from the batter will the ball be when it hits the ground? So I take my x equation, and I multiply by the time that it was physically traveling, and that will get me my answer. It's 255.025 feet. To do part D, we're going to use the fact that they tell us that the fence is 250 feet away. I'm going to use my x equation to solve for t. So when you divide over, you should get that t is 3.738. And I'm going to plug that into my y equation. And I need this to be bigger than 10 to see if I clear the fence. There should be a plus sign, sorry. This comes out to be 168.302 feet, which is way bigger than the 10-foot fence. So yes, definitely going to clear the fence.